Welcome to TEC2. I'm Dave Herman with Tech Support. Today we're going to be going over static pressure, external static pressure of a furnace. Nowadays there's a lot more problems with static pressure due to the variable speed furnaces and expansion valves used with AC. So static is a lot more of an issue now than we've seen in the past. So that's what we're going to go over today and hopefully familiarize yourself with that a little bit better. Okay, today we're going to be using a field piece dual port manometer to take our readings of static. On this unit we'll have our hoses and our two probes. On these probes there is an arrow on the back side that is pointing the direction we want to be into the airflow, and on these probes that is tip, the sharp point, is going to be pointing into our airflow. So whatever way our air is coming, we want to be pointed into that. So our tip will be in the airflow. Okay, so I'll take my manometer, which this manometer has a magnetic connector on it, so I can hang that from the furnace. So I'm going to turn that on. I'm going to make sure I'm set for water column. We will read this in inches of water column. And the next thing I'm going to do before I insert my probes, I want to make sure I am zeroed out. So I am going to zero out on my meter. Make sure I'm at 0. Once I'm at 0, I'm going to take my P1 probe. I'm going to insert that into my return duct. That will be pointing into the airflow. Sharp point, the tip, will be pointing in. Once again, I could reference my arrow also on these probes. They are marked. I'll insert that into the spacer between the return of my furnace and the air cleaner. And then I also have a spacer between the top of my furnace and my coil, which I will insert there. Once again, pointing into the airflow. From there, I could go back to my manometer and I check for my readings. For the sake of filming today, we are using 2 manometers. One is being viewed by the camera, and then the one that I'm holding here. The P1 I'm reading is 0.1. My P2 reading is 0.18. So I'll take those two. I don't care if it's positive, negative. That's not going to matter in this situation. I'm going to add those two together. That will give me my total external static for my furnace. So once again, I take my 0.09 and my 0.19, and that gives me a total of 0.27. Once again, the meter that you may be seeing on the screen may be slightly different because that is being viewed at a different spot in our lab here. That is our total external static for our furnace, 0.27. Okay, now that we've checked the external static for the furnace, to the furnace, if those numbers don't necessarily seem ideal, we're in a lab situation, so we don't have full duct work. We don't have the perfect setup, or we don't have a normal setup you'd normally have in a house or some type of building where you have full duct work and everything actually fully connected. But if you did run into a problem where your external static was extremely high, there's other things you could look at. So you start wondering about, possibly your filter or your air cleaner or maybe your evaporator coil. So the same way you check static with the furnace, we can do the same thing with the air cleaner or the evaporator coil. So what we're going to do now is the same thing. We're going to start off, make sure our manometer is on. We're going to make sure it's zeroed out. And then we're going to check on each side of our air cleaner. On this one we have a Carrier air purifier. We'll start by putting our probes in on each side of our air cleaner. So we'll insert once again. Look at our arrows. We want to insert into the airflow. So we're pointing into our airflow. I'll insert on one side between the air purifier and the actual furnace. And then I have a hole here on the other side, and I'll insert on that side. And once again, I can check between my P1 and P2. I want to make sure all my hoses aren't pinched anywhere or caked, so I'm getting a good true reading. My P1, I'm showing a 0.09. My P2 is a 0.03. Once again, on this manometer, it gives us a total reading, and that would be a 0.07. So that's my reading for my air cleaner, my air purifier in this case. So from there, I'm going to move, and I can do the same thing with my evaporator coil. Whether it would be a case coil, which we have in this instance, or if it was an uncased coil that was inside the ductwork, we just have to find our location of that coil and make sure we had some kind of opening, preferably a hole, clean hole drilled in, like we do in these cases, above and below, so on each side. So same way, once again, because I'm starting over, I'm going to zero out my manometer. I'm going to make sure I am at 0. Once I'm at 0, I'm going to again take my probes, place them in position. Once again, in these probes I'm going to be pointing into my airflow. So with the probes in, I check my P1, I'm at 0.17. My P2, I'm at 0.12. So my difference was 0.5. Okay, now that we've checked all our statics, we got an idea what's going on in the system and how things are working. So with the furnace, the external static with the furnace, ideally we're at 0.5. Design would be 0.5. So if we're higher than that, that's obviously not good. We want to be at that 0.5, or as close to it as possible. So as then we start to check other items in the furnace or in the ductwork system like we did, we check our coil, we check our air cleaner, air purifier, or filter. If we find that those are okay also, then we have to start looking past that. We start looking to our ductwork to see if we have a sizing issue with our ductwork, if something has been blocked off, closed, damaged in some way possibly. But everything is going to reference back to what we're seeing, what the external static is by the furnace. We just kind of work from there and work our way out to see where our problem actually is. With the 0.5 static we have with our furnace, our external static, we can check our evaporator coils, we can check our air purifiers manually with our manometer, but we could also reference that with product data that the manufacturers provide with the equipment. So we could also look that up, but that also might not be accurate depending on the age of the equipment, if it's dirty, if it's worn, if the evaporator coils may be damaged slightly, so you may not have the ideal airflow through them that you did when it was brand new. So that's not always going to be perfectly accurate. So sometimes it is a good idea to actually physically check them instead of just referencing the product data, the information that the manufacturer does provide.